for today then. So yes, sir. Is the screen visible?
Yes, visible. Okay, let me give a short introduction.
Yes, sir.
Students, as we are entering our 15th day of our workshop, we are going to see about the bioanalytical instruments. The first session will be about HPTLC, high performance thin layer chromatography, techniques and applications. We have with us Mr. Siddesh Tari. He is an application chemist from Ancrom Enterprises. Ancrom is the leading company in India when it comes to HPTLC instruments. Mr. Siddesh works in developing methods, different methods for a wide range of samples like herbal, pharma, cosmetics, forensics, food, and a lot more. He has also have a 3 years of experience in column chromatography. He have handled LC-MS and have worked on different makes of LC-MS like Agilent, Shimatsu, and Waters. He has worked on different method development and also 5 years of work experience in teaching SSC students. He has delivered presentations to various customers of HPTLC and also providing trainings in troubleshooting HPTLC system, HPTLC applications as per their requirements. He has also developed several new HPTLC methods for customers in pharma and herbal research. Basically, he has an education in chemistry, BSc in chemistry from Mumbai University and a master's in analytical chemistry from Mumbai University. So with this short introduction, I invite Mr. Siddesh to deliver the lecture.
So thank you so for the introduction. Good morning, all students. We'll like to start a video or our session with this part. Like if you are able, I think everyone is able to see my home screen. So we are going to talk about high performance thin layer chromatography, the technique and the application, as well as the instruments which are used. Starting with those, we'll first try to look for if you want to reach to us, there are different sites or there are different links or portals through which you can reach us. That is from LinkedIn, Facebook, YouTube. We have a YouTube channel where we post different types of videos related troubleshooting as well as the instruments or how the software can be used. We have LinkedIn as well, where we are so completely active for different types of methods which we develop. We have developed very different methods. If you try to see it in LinkedIn, you will be able to see that we have developed different methods for various pharma, herbal, and a lot more. So what talking about HPTLC, we are in this we are in this training since 1994. We have provided in our instruments to different government labs. We provide training to all over the cities in India. Then there we issue the certificate for that as well, even the person is getting trained for the same, so that it can be used for their reference for the further. So as I was talking about my YouTube channel, which is or the Ancrom YouTube channel, you can see we give training videos. We upload.
Slide is not moving. Second slide. It is in first.
Sorry.
It is still in the first slide.
Is it moving now?
No.
Just a minute, sir. Is it?
Yes, yes.
Yes, thank you. As I was talking about, this is our Ancrom YouTube channel, which I was talking about. So here we give different types of training. We provide different types of training videos. And right now as well, we are having certain employees of which are working for the same, that they provide videos or informative videos for different instruments, different softwares. Like we earlier had WinCats, we had videos for WinCats. Now we have upgraded to VisionCats. So we are trying to make it more compatible to the customer for WinCats or VisionCats more probably. So there are lots of videos which you can use for your references. Then let's talk about HPTLC. So talking about HPTLC, the HPTLC word is evolved word. So we'll first start with TLC. So what was TLC, how it evolved? So here is the complete scenario for it. Like in 1960s, it was TLC. Then it came to be an instrumental TLC, wherein it upgraded itself further to software controlled TLC, then GLP compliant TLC, then HPTLC methodology came into practice, then pharmacopoeial HPTLC 2018, which was introduced in 2018. Then we introduced regulatory compliant, and now in 2021, sorry, that's 2022, we have introduced a completely robotic HPTLC. So we are going to talk about all the aspects and how we have evolved from TLC to our new word, that is HPTLC, that is completely robotic. So first, when we talk about TLC, what we see is this kind of images, right? This is an uh, this is an image of a spotting which is done while we are doing TLC. Does that look any interesting, or does that look an image which we can be able to issue or we can publish it, right? We can't publish this kind of images because it is very blur, and the separation of the bands are not very clear, to be precise. So, but now just let us compare this with HPTLC. So this is also ginseng species. The same sample is applied in both the cases, where earlier when it was applied using spotting technique, you can see that the separations which are present there are not that clear. Whereas in this HPTLC analysis which we have done, the separations which you see are very much clear and you can identify that. And how we have evolved it more further, we'll see in the further slides. So when I was talking about this part, this was the earlier TLC, and now when we talk about a robotic HPTLC, this is what we mean. So we can see that there is a lot of difference and upgradations from TLC to HPTLC. So we are further going to see that what are these upgradations and how these upgradations have changed TLC to a new phase, which is robotic HPTLC. So basically, when we go for a TLC, where we use different types of plates, and according to our plates, we get different types of resolutions. There are different kinds of plates which can be used, like silica gel. There are two different sizes of plates generally used. That is a 20 by 10 centimeters and a 20 by 20 centimeters. When we talk about a 20 by 10 centimeters, it is generally used in pharmacopoeias, because they or when we talk about 20 by 10, it is used in herbals as well. Whereas 20 by 20, it is generally used in pharmas for identification of impurities or certain things. So here you can see, even if it is a 20 by 10 plate, the resolution and the separation is different or can be seen that it is more better than a 20 by 20. The reason is, here we are using HPTLC plates, whereas the 20 by 20 is a TLC plate. So this makes the difference, as you can see. So what it does is, what we have done is, we have just made it more miniaturized so that it can lessen the time, sharpen the bands, and more samples can be applied. If you are able to see in this 20 by 20 plate, the number of samples which are applied, it might be 8. But here we are applying number of 15 number of tracks, which is more, or we can apply a lot number of samples at a time. And also the amount of solvent which is required is very less compared to a 20 by 20 plate. So coming over here, HPTLC system and the output. So these are all the systems which we use. Sorry. These are all the systems which we use. These are all the systems which we use for HPTLC system and data output. The first thing I like to highlight you is our VisionCat software, which is denoted to the complete right of the system. That is the complete heart or the complete software, which which controls all the instruments in a link. And through this links, you can just complete your whole analysis and record your whole analysis simultaneously. So how it is done is, earlier when we talk about TLC, what we used to do is, we used to take a normal glass plate, we used to take a capillary and just apply a spot at a position with random amount. We could have made the concentrations correctly, but what we have to do is, we can't get the application volume correctly. So here what we do is, first the applicator does that work for us, that we can apply a known concentration and a known amount of sample on our plates, or the standard on our plate, so that it makes us more easy to identify the concentration of the unknowns from the a sample, or we can identify fingerprinting from the sample as well. So talking about first, it was applicator. Then this applicator has done our work for application of the sample or standard on the plate. Next we go to the developer. So talking about developer, we'll just compare it first, and then we'll see how it has evolved and what are the different things or the plus points of this technique or using this technique. Then talking about the development chamber, earlier what we used to do is, we used to take a glass jar and we used to pour an amount of mobile phase or whatever solvent which we have made a composition of, and we used to introduce our plate directly inside. We never used to measure the amount of solvent which we have taken inside the chamber. There were chances there were chances that the solvent might have touched the or might have been introduced earlier before development to your sample of analyte which we are trying to separate out. So that might lead to the errors, as well as the plate which we are talking about. The plate might be uneven, so that unevenness on the plate will not give you a proper separation. So using a good quality plate, which is a HPTLC pre-coated plate, we have eliminated we have yes, anyone wants to talk? I think someone's mic is on. Sorry. Yes, so we have eliminated the error by, what we have done is, we have eliminated the error by using a pre-coated plate, so that the unevenness of the plate is been eliminated or removed. Then we use a proper amount of solvent, so that the solvent or the sample which we have applied on the plate doesn't get introduced to the solvent earlier, and it can run through the capillary effect only. Then we have a visualizer over here. This visualizer takes image of the plate in 3 different wavelengths. The only the only wavelength which is visible to us, that is the white light. Also, it takes images in 254 and 366 nanometers. There is an industrial grade camera which is set onto the instrument. If you are able to see the cursor of mine, which is showing the image, or which is showing the camera location, that camera is all prefixed, which adjusts itself according to the size of the plate. In this visualizer, you can take an image of 10 by 10, 20 by 10, and a 20 by 20 size of plates. Then after visualizer, we move to the scanner. This is a scanner 4. This scanner 4 gives you a range of 190 to 900 nanometers. I would like to repeat that this scanner gives you a range of 190 to 900 nanometers, which means that from a low UV to a very high UV, as well as white light and fluorescent. This gives you a complete range in which you can scan or take the spectra of your images. The arrow which is showing from the scanner can show you, is depicting you that how the images or how the scanning reports are being observed. The graph is absorbance according absorbance and concentration, amount of light which is absorbed and raised to its concentration. Then this is the part or for completion of our analysis. But sometimes what we have is, we need our sample to be analyzed through mass spectroscopy. So while going for a mass spectroscopy, you need to scrape it. Generally, in basic HPTLC technique, what we have to do is we used to scrape the bands which we have obtained, dissolve it in a particular solvent, and then go for an MS. Filter that, yes, also filter that and go for MS. But here we have an MS interface which helps us to take the band of interest and pass it directly to the MS without eliminating all the factors of scraping it out, removing the part of interest only, and loss of solvents or loss of analyte while dissolving it. This after that, uh, here the arrow which is showing depicting the image which we can get through the MS interface. Then talking about the derivatizer. This derivatizer is a spraying technique. In this spraying technique, sometimes the bands which are not which we can't observe under white light, we need to derivatize those bands. Derivatisation, here the derivatisation is a destructive technique. Once derivatized, can't be reversed. Then second point under derivatization comes that there are different types of derivatizers which we use. Some are specific derivatizer, whereas some are universal derivatizers. We'll talk more about it in the further part. But when we talk about derivatization, what it does is it adds a chromophoric group. I'll repeat, it adds a chromophoric group to your band of interest or to all the bands which are separated, which helps you to see it under a visible wavelength, as it is showing an example above. So, HPTLC quantification. Now, as I told you that applicator, what it does is it can apply a known concentration and a known volumes. A known volume, that's more important, because if you know the volume, you can identify the concentration of your known standards so that we can quantify the analysis. So what we do is we used a standardized methodology to make the standard as well as the samples. Then we go for a validated methods. There are different methods which are validated for the same. Then we have a software controlled hardware, where the manual error is completely eliminated. Then we can go or we can reach to a sensitivity of nanograms or picograms. Nanograms in UV absorbance and picogram in fluorescence. Then we have a reproducibility rate of plus or minus 2%. Then we have accuracy precisions, then multiple detection without repeating chromatography, then MS hyphenation, and then fully regulated compliant worldwide. We are fully regulated and compliant worldwide. So using all those steps, what we do is we can do a quantification of your analyte if it is present in the sample. So before going to quantification, let's talk about HPTLC fingerprinting. What is a fingerprinting? How can a fingerprinting be done? And all those sort of questions. It is an image of the, it is the electronic image of visual HPTLC chromatograph. Based on the RF colors and intensity of the bands in the electronic image, account of 100% of the sample for comparison with botanical reference material, can be stacked of multiple images in different detection modes, that is 254 nanometers, 366 nanometers, and white light. I'll give you a more lower or more elaborated ways to explain. I'll go a more elaborated while explaining fingerprinting. So when I talk about fingerprinting, it is basically like what we have are fingerprints. Each of the sample or each of the plant or a formulation will have a different or a unique fingerprinting. What we do here is we elute the samples in a particular mobile phase or or different types of mobile phases, so that we can identify that what kind of bands or what kind of analytes are present in the sample, and we can get a B RM, which is a botanical reference material to identify the specific marker from the sample. So when I was talking about each fingerprinting is different, here it is, HPTLC fingerprinting. That means that there are same species or the same pipers, but there are different species of it, and each of them will have a different fingerprint pattern. So here it explains that Piper nigrum and Piper longum, even if they are from the same family, the species will have a different fingerprinting. Then there is a comparison. As we are comparing this, we'll just move it quickly through there, that planar, both of them are planar chromatography. The primary focus is for simplicity and low cost. Here it is reproducibility and separation power. Then it is a flexible and here in HPTLC, it is a standardized methodology and optimized parameters are used. Then there are very few parameters, whereas in HPTLC we have a well for defined and validated parameters. The flexibility here is high. As we are using a validated method, there are none of the flexibilities available. We have to follow the validated methods. Then the target is for TLCs to be a rapid and preliminary results. But here in HPTLC, we have reliable analytical results. Then talking about data structure, you can't just take a photograph of it. Whereas in HPTLC, there are traceable digital images, scanned data, and a lot data for the same. Then in sample references, side by side on one plate, you have to apply the sample and the standards. Whereas on the same or on the different plates, days and labs can be analyzed using the comparison viewer. Then plate size in TLC, any format of plate is used, whereas in HPTLC, we used a particular or a given plate format that is a 20 by 10 centimeters plate. Then instrumentation, there are none of the instrumentations, whereas in HPTLC, there is a very sophisticated instrumentation. So why is it HPTLC very reliable, fast and safe? Because it is a fast and safest chromatographic method. It uses a very low running cost and maintenance. Multiple detector eyes, electronic and bioactivity can be done, and so on. So how the stepwise practices of HPTLC is done. First, the software activation, application on plate, chromatographic development, image documentation, densitometric scanning. Then we move to MS, IRNMR or derivatisation or bioactivity EDTA, image documentation and scanning. We'll move to this when we are moving or when we are talking about the applications. I want to introduce you to the applications or the instrument and their application first. So here it only tells you about the USP which we follow. There are different methods. This all methods are being set in the instrument for the same. Like in the first, we are showing you here is the developing distance and all the application patterns on this. How the plate, this whole image is of the plate, and the first A, which shows the 20 nanometers of distance from the plate edge. Then C, what over here, it shows the band length, then the distance between it, and all those factors, the developed solvent front and how the RF will be calculated are all pre-applied or pre-noted in the instrument software. Then there are different factors which affects the things. There are that is relative humidity. The relative humidity or the humidity plays a very important factor when we are talking about chromatographic technique. When we are talking about planar chromatographic technique, the humidity in the atmosphere can change the what we can say the RF values to a very fluctuable range. So we use a humidity controlled system. So I just want to move over here to the sample preparation. Here in this sample preparation, it is a very simple and universal method for sample preparation of botanicals. Like whenever we are having a sample, we take the sample and we weigh it to 100 mg, and we add 1 ml of methanol. 100 mg is to 1 ml. That is the ratio. Then we sonicate it for 15 to 20 minutes, centrifuge it to 5000 rpm for a few minutes, and use the supernatant. It is most simple, economic, and fastest application sample uh, extraction technique. This supernatant is further used for the complete analysis of the sample. Here, the methanol is not a compulsory factor. The solvent, whichever your part of interest of analyte is getting dissolved into, you can use the same. So this is where I wanted to introduce you to our systems hardwares. That is the applicators first, Linomat 5 and ATS 4 automatic sampler. So here you get when we talk about Linomat 5, it is a semi-automatic instrument, whereas if you are able to see the blue syringe, that part, or it is called as a turret, and you have to fill and clean the syringe each and every time manually. Whereas when we talk about ATS4, if you are able to see behind, there are two different bottles, that is the waste bottle and a rinsing bottle. This bottles, you have to just fill it once, and each and every time of the application, the system will automatically rinse and clean the syringe it on itself. Both of the applicators does the bandwise application, and when this application has been done, the plate is not at all disturbed. That is the reason why we get a precision and accuracy, and it meets all the regulatory norms. So that when I talk about that, all the applications is done without touching the plate, it means that it is not at all contaminating the plate or the samples. Then let's move to the applications technique. What are the different type of application techniques? Then when we talk about quantitatively identification, we have a standard and we have a sample. So the first slide, or the first plate, shows the quantitative way and how it is applied. We applied samples in duplicates, whereas standards in between them, so as to maintain the uh, ratio or the balance for the plate, and it is developed to a particular distance. Then in situ cleanup, here we apply it at 110 millimeters above. Here it is used to separate the fatty matrices from the sample. First, it is run or developed in different developing solvents, that is in ether or maybe like that, and then the plate is dried so that the fatty layers or the fatty matrix is separated from the sample. Then the plate is turned around to the 180 degrees, and actual development of the plate with our initial analyte separating mobile phase is done. Then when we talk about micro preparative isolations, this is done when we have to isolate a particular analyte from our sample. Then talking about superimpose. Superimpose, it is done for spiking, or it means that when we have to identify or quantify a sample or the analyte from our sample, we superimpose that. It can also be done using the applicators. Then talking about the development part. This development parts, there are three different things which you can use, or three different instruments which we can use. Out of one is the twin trough chamber. This twin trough chamber, it is called a twin trough chamber because if you are able to see the first image written twin trough chamber, clearly there is a trough in between which separates the, or which distinguish the chambers in two different parts. One of the part is used for saturation, whereas second part is used for the development of the plate. The same chamber is used in the automatic development chamber ADC. Here, when we talk about ADC, it is a completely automatic chamber where you have to just introduce your plate inside. It will automatically saturate the chamber for 20 minutes. It will develop the plate at a particular wavelength or at a particular length, which has been noted in the software. And also the humidity will be controlled over here. It means that even if you are doing the analysis in different humidity conditions, the humidity inside the chamber will be maintained and you will get the same RF values or the same results each and every time you perform the analysis. Then talking about gradient elution chamber, the gradient elution chamber is what it does is it is used for development of the analytes which are having different polarities. If you are able trying to identify, if I am, yes, this is what I'm trying to explain in the gradient developing chamber. Here you can use different mobile phases according to their polarity and according to the analytes which are present in the sample. You can use uh, nearly 5 solvents to separate your band of analysis or the interest of analyte according to the polarity. Then talking to about stationary phases, there are different types of plates like cellulose plate, silica gel plate, glass plates, which are pre-coated, which can be used according to our requirements. Then, as we have talked about ADC2, which explains it is a completely USP compliant, then it is software controlled, fully automatic. Humidity can be controlled, a layered equilibrium can be obtained, and automatically drying of the plate as well as is done. It means that after application, if you are introducing your plate in the ADC2 chamber, you will get a completely dried and developed plate from the chamber, which can be further taken to the analysis or further taken to visualizers. So how the gradient development works, it is showing over here. If the analyte is not getting separated in polar phase, it can be introduced to the mid polar phase and further to the non-polar phase so that all the analytes can be separated from the sample. So then talking about visualizer, as I told you, the visualizer is uh, equipped with a very high industrial grade camera, which takes images in 3 different wavelengths. That is white light, 254 nanometers and 366 nanometers, which is fluorescence. So here is a comparison of multiple examples of curcuma. As you know, there are different samples of curcuma. This is showing you the presence in 3 different wavelengths. And these are all different species of curcuma which are used in different labs. And you can see we have obtained a very well equilibrium in the same. Like you are able to see the RF of each of them are at the same. This analysis are done in different labs, different species, and by different analysis. Still, the data is been traceable because of the software. Then we're talking about the scanner. When we talk about scanner, it takes lights in UV, visible, and fluorescence. It has a wavelength of 190 to 900 nanometers, and it can take a spectras as well for the identification. So this is how the scanner works. If you're, I'd like to play it again. So as you can see, when the light passes through the band of analyte, you get a peak of interest. It is absorbance as in a line versus concentration. So this is an absorption spectra of bands in which sulfomethoxazole is explained at different wavelengths, as well as 2 different analytes are explained at different wavelengths. So it is showing that all the three are having different spectra and have a different lambda max, which can be identified easily using the spectra or the using the scanner. So when it is to identify, it can be identified in two different ways, where we have to identify it if the band which we are obtaining is the same, or we can check for the purity of the band as well. If the co-eluting analyte has been uh, disturbing or is interfering with our band of interest, we can identify that as well using the purity of the spectra. Then we can also have multi-wavelength scanning, which means that you can scan the same plate at a time in three different wavelengths or more. Then you can do the quantification as well using the scanner. As I said, the concentration according to the absorbance of light absorbed, which is been shown. Through that, a calibration curve or a calibration line can be observed, or a regression line can be observed, on which you can identify your band of or interest or quantify your band of interest. Then moving to the derivatizer. That is, derivatizer is it works on a spraying technique, and it has a piezoelectric effect. A piezoelectric effect means a very thin film is present in the spraying sprayer of the derivatizer, on which, provided the electricity, the thin film vibrates, which is called the piezoelectric effect, and the mist is formed. This mist is introduced, or this mist is settled on the plate to get a equal derivatization. The plate is completely derivatized, or the plate is equally derivatized on all the parts. Then post chromatographic derivatization, as we can see over here, this is a Camac plate heater. When derivatization is done, the plates need to be heated to remove the excess of the solvent or the other components. So Camac plate heater is used. It is a very high sensitive instrument which can reach to a temperature nearly of 200 degrees Celsius as well. This is used so that the plate can be equally heated from all the parts, or all the parts of the plates can be equally heated, and uniform heating can be obtained, which is not possible in different ways while we use microwaves or the same. Then class of compounds detection by the post chromatography in situ derivatization. There are different class of compounds which can be done using HPT or HPTLC techniques, like alkaloids, anthracins, beta principles, tannins, coumarins, essential oil, flavonoids, and lot more. Then talking about the MS interface. When we talk about MS interface, here what it does is it takes a fraction from the plate, and this fraction is introduced to the MS. Here I will like to show you a short example of how the interface works. If you are able to see, the orange part which is shown on the plate is the band to be eluted. So how it will be eluted is shown in this short video. As you are able to see, the MS interface head has locked the band, and now it will, through HPLC pump, all the analyte of interest will be dissolved in the solvent which is present in the pump, and it will move to the MS spectrometer. While moving, there is a frit which is present on the outlet, which only allows the solvent to pass through to the MS and not the silica, and where you get the complete MS or the complete data for the same. Then HPTLC method validation. When we talk about methodology, we have method validations like specificity, precisions, interday, intraday, accuracy, linearity, limit of detection, limit of quantification, and ruggedness is done using HPTLC, where if the sample is having a particular amount of analyte which needs to be quantified, or we have if anyone wants to and analyze the same for the any plant or any formulation. It can be done using all these techniques. We can quantify it and validate the method for the same. While we are doing all those, we need different literatures, book surveys as well. So these are some literatures and book surveys which we do, like HPTLC association. HPTLC association has different different a very lot variety of mobile phases or analysis files which can be used while a person is analyzing, as well as CAMAG. There are different application notes which are present of CAMAG for different herber formulations, which helps when you are going for an analysis. Similarly, there are some books which are given in the same. Then, talking about application areas, we have applications in pharmaceuticals, foods, botanicals, industrial areas, forensic, organic chemicals, reverse engineering, etc. We'll just move to one or two examples, like here, identification of a cassette tree leaf, and here where we have done the fingerprinting of it. If you are able to see the table below, it is showing that various standards were applied and the samples of the same were applied, and we can see that we have identified those markers in the same extract or the leaf extracts. Similarly, we have done the identification of ashwagandha, which is Withania somnifera, by HPTLC fingerprinting. Uh, is my screen visible?
Yes.
Yes, sir. So, talking about different pharma applications, I like to explain this part where we need to identify the quantity which is present, which I was highlighting each and every time over all this topic which I was talking. So here you can, this is how it explains. Here you can get apply a known concentration of the Assam standard on the plate and apply your unknown concentration or the sample, and you can get a proper detailed calibration curve for the same. I like to explain or elaborate it by showing this part. Like here we have applied different concentrations. If you are able to see from track number 1 to track number 7, the standards of different concentrations are been applied, and they are been identified in the sample as well. And this unknown concentration is received in the graph.
Siddesh, I think the slide is not moving.
Just a minute, sir. Is it visible, sir?
Yes.
Yes. So as I was saying, from track number 1 to track number 7, different concentrations are applied, and the different concentrations of the samples standards are applied, and they are identified in the sample. And as they are identified, we get a calibration curve of quantity versus the absorption. And on this basis, we identify the concentration which is present in the sample as well, as you can see it in the result box which is present below. So this was all about us and all about HPTLC and the different instruments. So I think we are completed with the presentation. If there are any questions, sir.
Yeah, thank you, Shivdesh. The
Yes.
session is open for discussion. Students, if you have any clarifications, you can ask Mr. Sanjesh. There is a question from Manjali Sharma. How HPLC is different from HPTLC in terms of efficiency?
So Uh, first of all, I would like to enlighten you that HPLC, while we are comparing HPLC with HPTLC, both are completely different techniques where HPLC is a column chromatography and HPTLC is a planar chromatography. Here, there are both profit and losses from both the concepts or both the aspects. Like when we are doing HPLC, it is a very time consuming, you are a analyte of interest or a very large amount of analyte of sample you have to use, or there is a very long and lengthy procedure for the sample extraction. Whereas in HPTLC, the sample extraction procedure, as you have seen, is a very simple and a easy sample way of extracting the sample. Applications is also simple, and you will get the result in a plate. And different R&Ds compared to the time efficiency, different R&Ds are very much easily possible.
Next question. Any other questions?
Yes, Kadambari, thank you for that. Okay, so the how cost effective can a HPTLC run be when compared to TLC? Yes, as it uses less solution, we'll go more detailed about it if we are having this discussion. So when we compared, we said that it is a preliminary technique. There are different aspects which enlightens or which helps makes us that we have to choose HPTLC but then TLC. They are like, first we talked about a plate. The In HPTLC, we use pre-coated plates. These pre-coated plates, what they do is they are pre-coated. There are what we can say is, when we use glass plates, the surface of the glass plate, we can't assure that the silica which is present on the glass plate is equally spread and it is having an density of equalness on throughout the plate. Whereas when we talk about a HPTLC pre-coated plate, the thickness of the plate is equally distributed. That is the factor which affects or which makes the results of HPTLC more better and effective than TLC. Due to this results, what you have to do is you don't need to or you don't require to do the analysis again and again, which is very time consuming as well as cost consuming. Whereas secondly, we use uh, what we can say measured amount of solvent, like as you said, it uses less solvent. When we talk about a 10 by 10 centimeter plate, we use just 10 ml of the solvent for the development. Whereas when we are talking about a 20 by 10 centimeter plate, we use only 20 ml of solvent for that. as well as when we are using a 20 by 20 plate, we just use 35 ml of solvent for the same. So if you're able to see whatever the composition may be, we are reducing the composition to, and we are reducing it and limiting it to a constant or to a limit of 20 ml, 10 ml, and 35 ml, which is a minimal concentration, minimal amount. So it is very cost effective. And as you are getting better results in early performances, your time as well as is saved. Yes.
Next question. Anyone else? No more questions, then I would like this opportunity to thank Mr. Siddesh for joining us today and elaborating about the principles and instrumentations of HPTLC. Thanks to Siddesh and Chrome Enterprises. Thank you,
Thank you, sir. Thank you, sir. Yeah.
Good morning, Dr. Amrutraj.